The world's three superpowers, the United States, China, and Russia, are all developing a new class of weapon system known as the Hypersonic Glide Vehicle, or HGV. All of them function largely the same. In a similar fashion to their ballistic brethren, as multi-stage booster is used to push the glider to high altitude. After fuel is expended, the booster detaches either inside or outside the atmosphere. The glider will then either begin its gliding phase or coast outside the atmosphere before re-entering, respectively. Taking the glider outside the atmosphere may give it a longer range, but it also makes it easier to detect by ground sensors. Radars require a line of sight to detect targets, thus at gliding altitude the HGV is hidden by the Earth's curvature until it's 500 to 1,000 kilometers from the target. In the glide phase, the HGV is low enough in the atmosphere to utilize lifting force for maneuvering. Accuracy is greatly improved as the vehicle is able to make course corrections during the flight. This allows it to achieve a circular error probability of a few meters compared to 100 meters or more for ballistic missiles. Survivability is dramatically increased since the glider is able to stay outside the engagement envelope of anti-missile systems. Even if it enters the engagement envelope, it may still be able to stretch the maneuvering capability of interceptors. In contrast, ballistic missiles usually can't maneuver at all after separation from the booster, and thus their course is predictable. The low gliding altitude also makes current exoatmospheric interceptors incapable of intercepting the gliders. The current upper-tier U.S. ballistic missile interceptor, the GBI, can't intercept threats inside the atmosphere at all. The infrared seeker installed on its last stage tracks the target with extreme accuracy and allows the GBI to hit the target kinetically. However, heat generated by air resistance will warm up the sensor, adding infrared noise, which would wash out target signatures. Even that, a system designed to intercept within the atmosphere is unlikely to be able to intercept gliders due to the same seeker heating issue, though it might have a chance while the glider is in the higher initial gliding altitude early in the flight. On top of all those advantages, HGVs have a longer range compared to ballistic vehicles when using the same boosters. All of these advantages make HGVs immune to the current US missile defense system. With that said, gliders have some drawbacks. A glider starting at a speed of 6 km per second would have a speed of only 2 km per second after a flight of 7,000 kilometers. This is the speed of short-range ballistic missiles at re-entry, making them vulnerable to low-tier defense systems such as Patriot PAC-3, S-400, Aster, and David Sling. Another disadvantage is air resistance at such speed generates incredible heat, getting some parts of the glider to temperatures in excess of 1,000 degrees Celsius, possibly making the glider trackable via space-based infrared sensors. Current ballistic re-entry vehicles get quite cold at night and only reach medium temperatures during the day, making them very hard to track after the boosters have stopped burning. Further still, the low altitude of gliders makes it impossible to use decoys such as mylar balloons discussed in previous videos. And although gliders can maneuver to dodge interceptors, the maneuvering capability of interceptors is generally better than that of gliders, which must carry a very heavy warhead. Gliders are an emerging technology that can be used in conjunction with ICBMs to create a nearly impossible to defeat delivery method. However, they are certainly interceptable with the right missile defense architecture.